Well, welcome to Founders in Five. I have our good founder here, Partho. Partho, tell the audience about your company. Have you announced the company?
You know, we just
I was very careful to say whether am I allowed to say?
we are allowed to talk about ramen. We just
We can't talk openly about ramen.
We can talk openly about ramen now. We just came out yesterday.
Okay.
We timed it with Cota Connect, and I would describe it in the following way. If you think about the physical world of what we call the uncarpeted enterprise, which is a term we made up.
But I like the uncarpeted enterprise.
Yeah.
There's a lot of uncarpeted enterprises.
There's a lot of uncarpeted enterprise. If you think about square footage, it's probably like, 10x that of carpeted enterprises, right? But if you think of warehouses, if you think of shipyards, if you think of factories, there's, a bunch of environments. And what we see happening there is a huge transformation. Some of it is basic, but a lot of it is the possibility of using artificial intelligence and building these, more modern process control systems with, we like to say, an AI brain in the cloud and robots and sensors in the physical world. And we see ramen as being the glue, providing the technology that interconnects all of this stuff.
Yeah.
With something that is very secure, very reliable, and can be deployed with very little effort. So I want to emphasize that last part, because much of the technology, much of the innovation that we have created in this company is focused on solving those three elements: security, reliability, and very easy deployment.
Right. The core of the technology from what I understood, you can help me explain it easier, is that essentially there's a radio, installed on site in the physical world, but everything else is on the cloud. You deploy networks over your radios virtually. You manage them. You deploy those networks virtually. Say a little bit about the architecture. It's very unique, and also talk about the spectrum, the difference between that and Wi-Fi.
Perfect. So the first thing is, let me start with the last question first. The spectrum is, in the US referred to as CBRS.
Yep.
There are equivalent kind of bands being deployed, being made available in the UK, in Germany, in Japan, and so forth. Now, the interesting thing about this spectrum is that the FCC has just made it available, like a year ago, year and a half ago.
It's a public property.
It's basically a public property. If you're a large landlord, you can go deploy anything you want in that spectrum. It belongs to you.
Right.
And the advantage of this is, much like Wi-Fi in your home, you can turn it on and deploy it as quickly as you want to. It doesn't depend on a service provider. So that's very powerful. It's a game changer. And what we see happening is that the US is being a pioneer here. Other countries are going to follow. And from a technology standpoint, once you have a solution that's working in the CBRS band, just making little tweaks to make it work in the other bands is easy.
Right. So it's not really, you're not really a hardware-centric. You're most of a software-centric, because those radios are easy.
Exactly. So Bobby, absolutely. So that was your other question. And so you're exactly right. If you want to mentally think of the radios as being almost like commodities, kind of building blocks.
Right.
But then what's changing their behavior, what's controlling their behavior is software.
That's right.
And it's software that we have developed. And it's software that's controlling properties like what frequency does the radio operate on? What transmit power does it use? Who will it allow to connect to the network? This is all controlled by us. But we've gone one step further. What we have done is, for the software management of those devices, even for all of the software management, we've done everything based on cloud principles. So everything is a microservice.
Right.
So we don't actually have to physically bring down an access point to do maintenance. So much of the software architecture that we have is in the form of microservices, a container-based architecture. And as you said, it's all based on cloud principles. Now, this software can either run on the public cloud. Today we have it running on GCP, but it can also run on-prem. But we manage it in exactly the same way in both cases.
Yeah. No, I mean, I can envision, let's say, a military base. I can envision large port. I can envision even small cities where you have, you want to put cameras or security capabilities or all sorts of sensory for sustainability purposes or for climate control or what may be. This is a much lower cost solution than anything that I've seen in the past. So there's a cost advantage plus flexibility.
Absolutely. And I'll give you a concrete example of the cost advantage. If you had, let's say something, a very easy example. If you, in America, if you go look at warehouses, you'll typically have on the larger warehouses, like 1 million square foot. Outside the warehouse, you might have 2 or 3 million square feet. If you wanted to cover all of that with just Wi-Fi access points, between the cost of the Wi-Fi access points and the trenching costs to lay cable down to the poles where you would mount the Wi-Fi access points, probably cost you somewhere between $1.5 to $2 million.
Wow.
You need a lot of access points.
Yeah.
You need to cable to them. My guess is, with our technology, and of course, there's not a price guarantee, that you could probably do it at 1/10 of the cost, 1/10. So that's an area where technology is giving you the advantage.
The physics gives you an advantage.
The physics gives you an advantage.
And then your architecture gives you an advantage.
Absolutely,
Yeah.
Brilliant point. So the physics gives us an advantage because in this technology, you can transmit at up to 50 watts instead of 1 watt.
Yes.
On the receiver side, the receive sensitivity is much better. So you have basically a 30 dB advantage. So that's giving you a huge advantage. That's the physics.
Of course.
And then on the architecture side, what we've done with our software architecture is made it so that the network design, the deployment, even the monitoring is being done by software and algorithms, not 200 people sitting behind a desk.
So what does the company looks like, 2-3 years from now? How many customers, what size of a business are you going to be?
We think that in terms of number of customers, our projection is that 5 years from now, we hope to be somewhere between 500 to 1,000 customers. Mm-hmm. We think that the application of this technology is not just in the US, it's worldwide.
Yeah.
We also think that in terms of, the set of customers, even though we were talking about unlicensed spectrum, we actually think that in 3-4 years, a lot of the service providers around the world will want to work with us.
That's right.
Because using their spectrum, they can deploy our service to their customers. So we think that, we'll see a huge fan out.
It's interesting. So you're not only leveraging the public spectrum, you can also use the other spectrum and build enterprise solutions.
Because we can go to a Reliance Jio in India and say, for all of your customers, we have everything built out. Please take our software, our technology. If you'd like, you can put your brand on it and go deploy to your 100,000 enterprise customers.
Well, congratulations. And I am just watching. I'm watching the wonderful company you're building and the benefit that you bring to the customers. Thank you. Thank you for joining us today.
No, we appreciate it, and we appreciate all the support from you and the rest of the Cota team.
Thank you. Thank you, sir.